Hello, I'm Mr. Brundage with AARMOURTHERM, and we're here to do a test on two 6x6 pieces of 1/4-inch plywood with a paint company's radiant barrier coating in their exterior base on top of the plywood samples. We're going to run these samples at very high temperature because these are high temperature paints, so what we'd like to do is show the thermal qualities of these paints as they're being heated. Now the ASTM requires that you use a 6x6 panel of 1/4-inch plywood. Under ASTM E285, the flame test is a high heat test based on propane. Propane is approximately 3,300 degrees, and that can be looked up. We're using MAP gas here, methylated acetylene stabilized propadiene. It burns at 5,300 degrees. So we've decided to raise the bar on the heat because we want to do a 20-second test, and we want to find out what the transfer of heat is through this plywood as though it would be a person's home, whether it would combust or whether it would transfer heat. So we're going to take the first sample, which is the radiant barrier with the exterior base, and we're going to set it up in a stand, and we're going to impinge the center of this flame on this radiant barrier with the exterior base. And then in the second part of the test, we'll use the second exterior base only with the compound 2 flame out, and that's my compound that I've invented. So I'd like to set up the test. We'll first start by checking the ambient temperature of the sample, and then we'll set the sample up. All right. Our front side temperature is 72, and our back side temperature is 72. Now, what we'll do is I'll have my assistant here. He'll check the temperature when it's impinged and it's flaming. So we'll set it here. We base the distance on 5 inches here from the flame from here to the center of the sample, not 8. We'd like to use 5 because we can get a more accurate example of the heat exchange here.
The back is reading 71, 72 now.
Okay. All right, I'm going to start the test.
73, 74, 75, 76, 78, 79, 82, 85, 83.
That's 90
degrees.
20 seconds. So we have flame. We are on fire. So we've pretty well boiled the surface off of it because we have a radiant barrier that transfers heat, and it's percolating the gases back through the radiant barrier. Go to the back and check the back.
I got 502 on the front just a second ago.
Now check the back. Okay, we're flamed out, but we got quite a bit of combustion.
124, 140, 43, 'It's coming down slowly.
Mm-hmm. So this is a 20-second test. So now
Starting to go back up.
it should come up. Hold your laser at a center line straight in the middle of the impinged area.
159,
Okay.
161, seems to start going, it's going back down again. Must be going out. Okay.
All right. Now we're going to start the second test with the exterior base with the compound 2 flame out. So Compound 2F is referred to as compound 2 flame out because that is its real name. It means to flame out. Alright, now I'll get it up in there correctly. Alright, now ready? Now we ready?
Yep.
Okay.
Hang on a second, I got 78. 78 degrees Fahrenheit.
Get it right down close center. Make sure it's right.
Got right through the hole.
No, get it up
76
close to the
Get
sample.
close to the sample.
Okay.
I want a good.
78 degrees.
Okay. Are we ready?
Yep.
All right, now move back away.
Still at 78. 79. 80. 81. 82. 87.
There it is. Now we're on fire.
92.
We're out.
Oh, it put itself out.
Okay. Now.
99.
Go
Okay,
ahead
the
and
last was at 82, but it went up to 99.
All right. Now keep checking it. Yeah, check the back.
The back. 136. 130. Starting to go down.
Already you could see that the backside of the sample with the 2 flame out compound is dramatically reducing the temperature on the back side, which would be the inside of the house per se.
The thermal conductivity of the material shows a drastic difference. So what's necessary in heating and cooling is how much energy is transferred through a very thin coating. And in a fire, if you transfer that coating through, and that heat, it is trapped inside of a barrier. It can be trapped outside of it, but that heat can also be trapped inside of the barrier. We wouldn't want a flame to smolder inside of a barrier because it would collect nitrates from the cellular structure of the material and it would capitate the material, the nitrates into it and smolder. So a fire could theoretically start again. We want to dissipate heat as quickly as possible to bring it down to a stabilized temperature so that we can't cause reignition of a fire. So it's a very serious thing to dissipate the heat not only from the front side back away from it, but from the inside not to conduct through it. So this is a dramatic test to show.